Okay, here we are with lesson 13, changing scales. So for review, a scale drawing is a reduction of the actual drawing when the corresponding lengths of the scale drawing are smaller than the lengths of the actual drawing and when the scale factor is less than 100%. A scale drawing is an enlargement of the actual drawing when the corresponding lengths of the scale drawing are larger than the lengths in the actual drawing and when the scale factor is greater than 100%. All right, let's take a look at the opening exercise. You're going to work through the exercise on your lesson worksheet. When you are finished with each part of the question, compare and edit your answers by continuing the video. Go ahead and start with the first one. Describe using percentages the difference between a reduction and an enlargement. A scale drawing is a reduction of the original drawing when the lengths of the scale drawing are smaller than the lengths in the original drawing. The scale factor is less than 100%. Go ahead and do the next problem. A scale drawing is an enlargement of the original drawing when the lengths in the scale drawing are greater than the lengths in the original drawing. The scale factor is greater than 100%. So use the two drawings below to complete the chart. Calculate the first row, drawing 1, to drawing 2 only. All right, you should have this. The quotient of corresponding horizontal distances would be 3 and 92 hundredths, that's drawing 1, and drawing 2 is 2 and 45 hundredths. When you simplify that down, you should get 1 and 6 tenths. Doing the same thing with the quotient of corresponding vertical distance, you have 2 and 4 tenths compared to 1 and 5 tenths, and again that is 1 and 6 tenths. So the scale factor is a percent. 1 and 6 tenths is 160 over 100, which means it's 160%, so it is an enlargement. Okay, drawing 2 to drawing 1. We're going to go ahead and compare that using the completed work in the first row. Make a second conjecture or statement about what the second row of the chart will be. Justify your conjecture without computing the second row. Well, drawing 1 will be a reduction of drawing 2. We know this because the corresponding lengths in drawing 1 are smaller than the corresponding lengths in drawing 2. Therefore, the scale factor from drawing 2 to drawing 1 would be less than 100%. Since drawing 2 increased by 60% from drawing 1, you may incorrectly assume that the second row is 60% from the percent increase and 40% after subtracting. 100% minus 60% is 40%. This is not the case. Compute the second row of the chart. Was your conjecture proven true? Explain how you know. Okay, you should have the second row of the chart completed. The conjecture was true because the calculated scale factor from drawing 2 to drawing 1 was 62.5%. Since the scale factor is less than 100%, the scale drawing is indeed a reduction. So this is what you should have. If we take the reciprocal and flip this around, 2 and 45 hundredths to 3 and 92 hundredths, when we reduce that or divide that, we get 625 thousandths. The same thing happens with the vertical distances. So 625 thousandths, if we convert that to a percent, that means we would be dividing that by 100. So we are actually dividing it by 10 to get a denominator of 100. So that would mean this fraction could be written as 62.5%, and this would be a reduction. If drawing 2 is a scale drawing of drawing 1, would it be a reduction or an enlargement? How do you know? Well, it would be an enlargement because the scale factor as a percent would be larger than 100%. We will now discuss this exercise in length. synthesize what information you need in your math journal. Do not copy the discussion word for word. So if you reverse the order and compare drawing 2 to drawing 1, it appears drawing 1 is smaller. Therefore, it is a reduction. What do you know about the scale factor of a reduction? Well, the scale factor as a percent would be smaller than 100%. Recall that the representation from earlier lessons was quantity is equal to percent times the whole. It is important to decide the whole in each problem. In every scale drawing problem, the whole is different. Does the whole have to be a length in the larger drawing? No. The whole is a length in the original or actual drawing. It may be the larger drawing, but it does not have to be. So it is fair to say the whole is in the representation, quantity equals percent times the whole, is a length in the actual or original drawing. Since drawing 2 is 60% larger than drawing 1, can we conclude that drawing 1 is 60% smaller than drawing 2, meaning the scale factor is 100% minus 60% equals 40%? Is this correct? Why or why not? Well, no. To go from drawing 2 to drawing 1, a length in drawing 2 is the whole. So using the same relationship, a length in drawing 1 equals percent, P, of the corresponding length in drawing 2. Therefore, 2 and 45/100ths from drawing 2 is equal to the percent times the length 3 and 92/100ths in drawing 1. When we solve, we get 2 and 45/100ths over 3 and 92/100ths, which equals the P or the percent. This becomes 62.5%, not 40%. To determine scale factors as percents, we should never add or subtract percents. They must be calculated using multiplication or division. I can't stress that enough. When we are working with scale factors, we are never, ever adding or subtracting percents. We will only calculate this by multiplication or division because these are ratios. So in this example, we use the given measurements to calculate the scale factors. How could we create a scale drawing of a figure given the scale factor? Well, the original drawing represents 100% of the drawing. An enlargement drawing would have a scale factor greater than 100%, and a reduction would have a scale factor less than 100%. If you are given the scale factor, then the corresponding distances in the scale drawing can be found by multiplying the distances in the original drawing by the scale factor. Again, not adding or subtracting. So using this method, how can you work backwards and find the scale factor from drawing 2 to drawing 1 when only the scale factor from drawing 1 to drawing 2 was given? Well, since the scale factor for drawing 2 is given, you can divide 100%, the original drawing, by the scale factor for drawing 2. This will determine the scale factor from drawing 2 to drawing 1. Justify your reasoning by showing the drawing from the exercise as an example. So I've color-coded this. Drawing 1 will be in blue and drawing 2 will be in red. The scale factor from drawing 1 to drawing 2 is a scale factor of 160%. Again, drawing 1 would be considered the original, so that's 100%, and drawing 2 is 60% more, so it's 160%. Assume that this is given. Again, drawing 1 is 100%, and scale factor from drawing 2 to drawing 1 would be the following. The length in drawing 1, which we know as a percent, which is 100%, and the length of drawing 2. That would be 160% of the length. Well, in order to figure out the percent, we would have to divide 100 by 160. When we do that, we get 625 thousandths, which can, if we write that as a fraction, can be reduced to 5/8. So why is it possible to substitute a percent for the quantity, percent, and whole in the relationship quantity equals percent times the whole? Well, the percent which is being substituted for the quantity or whole is the scale factor. The scale factor is the quotient of a length of a scale drawing and the corresponding length of the actual drawing. The percent that is being substituted into the formula is often an equivalent fraction of the scale factor. For instance, the scale factor for drawing 2 to drawing 1 was calculated to be 62.5%. In the formula, we could substitute 62.5% for the length. However, any of the following equivalent fractions would also be true. So we could use 62.5 over 100. We could also write that as 625 over 1,000. We could reduce it down and use 125 over 200. We could further reduce it to 25 over 40. Or we could keep going, 2 45 hundredths over 3 92 hundredths, which is what we were given for the lengths. We could multiply that by 100, get 245 over 392, or we could reduce it all the way down to its simplest form of 5/8, keeping in mind that each one of these fractions is the same point on the number line, so that's why they are called equivalent fractions. Alright, so let's take a look at example 1. The scale factor from drawing 1 to drawing 2 is 60%. Find the scale factor from drawing 2 back to drawing 1. Explain your reasoning. Well, the scale drawing from drawing 2 to drawing 1 will be an enlargement. Drawing 1 is represented by 100%, and drawing 2, a reduction of drawing 1, is represented by 60%. So a length in drawing 2 will be the whole. So the scale factor from drawing 2 to 1 is length in drawing 1 is equal to the percent times the length in drawing 2. So we would set it up as 100% is equal to the percent times 60%. So when we solve this, 100% over 60% is the same as 1 over 60 hundredths. When we get that into a complex fraction, that is 1 over 3/5. Well, to clear that out, 1 divided by 3/5 is the same as 5 over 3, or 5/3. Now we're going to turn it back into a percent. So 5/3 multiplied by 100 percent would mean 100 times 100. And so 5/3 times 100 would be 500 over 3. And 1 times 100 would be obviously 100. So now when we convert 500 over 3 into a mixed number, we would get 166 2/3%. Alright, let's take a look at example 2. As a continuation to the opening exercise, now the task is to find the scale factor as a percent for each of the 3 drawings. A regular octagon is an 8-sided polygon with side lengths that are all equal. All 3 octagons are scale drawings of each other. So use a chart and the side lengths to compute each scale factor as a percent. How can we check our answers? So we have scale drawing 1 with side lengths of 10, scale drawing 2 with side lengths of 12, and scale drawing 3 with side lengths of 8. So using our table, we're doing the actual to the scale drawing. In the first row, this actual is drawing 1. The scale drawing will be drawing 2. So how do we do this? Using quantity equals percent times the whole. That means the length in drawing 2, which is going to be equal to percent times the length in drawing 1. Remember, the whole is being represented by drawing 1, and the quantity is being represented by drawing 2. So that means 12 is equal to percent times 10, and when we solve for the percent, we get 120%. So how do we illustrate the relationship? Well, the length of 10 times the percent, 1 2/10, which is the same as 120%, is equal to 12. All right, next let's do drawing 1 to drawing 3. Again, the length in drawing 3 is equal to the percent times the length in drawing 1. So 8 is equal to percent times 10. That gives us 8 over 10, or 80%. To check that, 10 times 80%, or 80 hundredths, is equal to 8. All right, now going from drawing 2 to drawing 1, that means the length in drawing 1, the quantity, is equal to percent times the whole, because the whole is now drawing 2. So 10 is equal to percent times 12, and when we solve that, we get 83 1/3%. To check that, and I'm not really happy with the fact that they're using a repeating decimal, I would keep it as 5/6. 12 times 5/6 would give you 10. All right, continuing on, drawing 2 to drawing 3. I'm just going to go ahead and reveal the answers. It follows the same pattern as before. Here is another instance where staying with 2/3 would be better. 12 times 2/3 would give us 8. And now drawing 3 to drawing 1 would give us a percent of 125%. That is 10 over 8. And because this is a terminating decimal, we can leave it as a decimal. 8 times 1 25 hundredths is 10. And last but not least, drawing 3 to drawing 2 would give us a percent of 150%. And 8 times 1 5/10 is 12. So to check our answers, we start with 10, the length of the original drawing, and multiply the scale factors we found to see whether we get the corresponding lengths in drawings 2 and 3. So drawing 1 to 2, 10 times 1 20 hundredths is 12. And drawing 2 to 3, 12 times 2/3 is 8. So why are all 3 octagons scale drawings of each other? All the octagons are scale drawings of each other because their corresponding side lengths are proportional to each other. Some of the drawings are reductions while others are enlargements. The drawing with side lengths that are larger than the original is considered an enlargement, whereas the drawings with side lengths that are smaller than the original are considered reductions. The ratio comparing these lengths is called the scale factor. All right, let's take a look at example 3. The scale factor from drawing 1 to drawing 2 is 112%, and the scale factor from drawing 1 to drawing 3 is 84%. Drawing 2 is also a scale drawing of drawing 3. Is drawing 2 a reduction or an enlargement of drawing 3? Justify your answer using a scale factor. The drawing is not necessarily drawn to scale. So we're given that from 1 to 2 is 112%, and from 1 to 3 is 84%. So what we know, or what we want to know, is drawing 2 a reduction or enlargement of drawing 3? Well, just by looking at the pictures, we know that it's going to be a reduction. But now we have to prove it. So first we needed to find the scale factor of drawing 3 to drawing 2 by using the relationship quantity is equal to percent times the whole. So again, the drawing 3 is the whole. Therefore, drawing 2 is going to be equal to the percent times drawing 3. So therefore 112% is equal to percent times 84. And as we solve for percent, that's going to be 112 divided by 84. And again, we can do this several different ways, but eventually we end up with 4/3. Well, now we have to take 4/3 and turn it back into a percent, so that would be 133 1/3%. Since the scale factor is greater than 100%, drawing 2 is an enlargement of drawing 3, which is what we said. Explain how you could use the scale factors from drawing 1 to drawing 2, which is 112%, and from drawing 2 to drawing 3, which is 75%, to show that the scale factor from drawing 1 to drawing 3 is 84%. Well, the scale factor from drawing 1 to drawing 2 is 112, and the scale factor from drawing 2 to drawing 3 is 75. Therefore, we must find 75% of 112 to get from drawing 2 to drawing 3. So 75% times 112% is 84, or 84%. So comparing this answer to the original problem, the resulting scale factor is indeed what was given as the scale factor from drawing 1 to drawing 3. All right, let's wrap this up. So when given 3 drawings and only 2 scale factors, explain how to find the third scale factor. Well, we can use the scale factors as the whole and the quantity. In the equation, quantity is equal to percent times the whole. The percent is going to be the scale factor. How are the scale factors computed when 2 of the corresponding lengths are given? Well, the length in the original object is the whole, and the corresponding length in the scale drawing is the quantity. Using the equation quantity equals percent times the whole, we can solve for the percent, which is the scale factor. All right, we'll see you in class.